All right, guys. Hello. Today we're going to talk about lesson 78, rotations. This is our last transformation that we're going to talk about, individualized. Okay, so our three different types of isometric transformations are translations, which is your slide, reflection, which is your flip, and rotation, which is a turn. Yeah, so this is the last one that we're going to talk about. And a rotation is just a transformation about a point. So we're turning it about a certain point. Okay, our first definition is going to be the center of rotation. The center of rotation is the fixed point around which a figure is rotated. Okay, so that will be the point where everything's going to rotate around. Rotations are assumed to be measured as a counterclockwise rotation unless otherwise noted. Okay? They're going counterclockwise. What does that mean? We start here, we're going counterclockwise, not the way the clock spins. Okay? For rotations, I'm going to let you write these down. Write them down somewhere where you can keep them, somewhere you can refer back to them, because they give you the exact mapping notation of them, and I don't survive without looking back to these definitions, formulas, whatever you want to call them. It's in the middle of page 511. It says for rotations around the origin. So around the origin is a big deal. Okay? Okay? If they usually go, in 90-degree increments. Okay? So if point XY is rotated 90 degrees about the origin. Okay, you will have the transformation, the mapping notation T dot XY will be mapped to negative Y X. Okay, that is a 90 degrees about the origin. Okay, if a point is rotated, a point XY is rotated 180. I'm going to move that back, sorry. Don't do that to me. Took way too much away. Sorry. So 90 degrees about the origin, this will be your mapping notation. Okay? If you're going 180 degrees about the origin. So all of these are the origin, so I'm not going to write it every time. You will have the mapping notation. XY will be mapped to negative X, negative Y. That would be 180 degrees about the origin. Okay? And last, if you were doing 270 degrees, these are the only ones that they will ever test you on. 270 degrees about the origin, you're going to go to, transformation will be, XY will be mapped to Y negative X. It's supposed to be a comma, then negative X. Okay? So they're going to go in 90-degree increments about the origin. So 90, 180, 270. If we added 90 again, that would be 360, and it wouldn't move. Okay? So if you have a point X, Y. So I'm just going to do just a little quick. If we have the point let's say 3, 5. Okay? And we want to go 90 degrees about the origin. It would simply be negative 5, 3. That would be the new point. If we wanted to go 180 degrees about the origin, we take the same point and it would be negative 3, negative 5. Okay, because if this x here to here to here was all 3, and the y was all 5, using this example. Okay, a 90-degree rotation, these are going to be still x, y, but this will be, you take your y that was here, which was 5, and make it negative. So it would be a negative 5. And then x, the 3, would become your y, your new y. Okay? If we were rotating 270 degrees about the origin, it would simply be 5, negative 3. And that would be your new point. Whew. Let's look at an example, okay? So, we have to recall these. We have to remember them. So, I've got a graph up here already. We're going to put a triangle because those are probably the easiest things to rotate. And I don't like that it's always an isosceles one. So, I'm going to move it to where it's not isosceles. I know that's not a drastic change, but to me, it helps. Okay, so point A is 2, 1. Point B here is 5, 1. And C up here is 4, 5. 4, 5. Okay, and if my instructions were rotate triangle ABC, I've got my little triangle mark. Let's just do 90 degrees. And they would say about the origin. So they have to specify which point we are rotating it around. Okay, so I like to envision a pin or a stake within that point, okay? And then there's a string attached to point A, and I'm going to turn and make that string go 90 degrees, okay? So I love these formulas, but I also like to visualize it also, okay? I can tell you all the coordinates without having to graph it. Sometimes they're going to ask for both things, okay? So my 2, 1, if you look back, looking at your notes, I'm going 90 degrees about the origin, will become negative 1, 2. Correct? Negative 1, 2. That will be my A prime. Okay? They switch places, and the X value, or which was the Y, becomes negative. Okay? Does that make sense? Stop and think about it. I'm going to rewrite it. The transformation of x, y will map to negative y, x. So if you see the point 2, 1, and I need it to map, take the y, this 1, and make it negative, and then the x is my next piece. And I'm putting it right there. Okay? That's how we're going to use that formula to plug it in. I forgot my T. That's what we're transforming. Okay? The next one, if I want to go with B. B, I'm moving, I'm rotating it 90 degrees. I need that to become negative 1, 5. So negative 1, 2, 3, 4, 5. That's going to be B prime. It's going to be negative 1, 5. So this line right here from A to B is this line right here, okay? So if we had transformed that line, like you can see my hands as I'm putting them up there, I'm sorry you can't. But if I take this line and say I want it to go 90 degrees, they should be perpendicular to each other if they kept going, okay? Just kind of envision that. And then C, needs to go to -5, 4. I think C prime, I will think 1, 2, 3, 4, 5. Yes. Is -5, 4. For some reason, I always do the one that's farthest away first. So, does it make sense? If I had that pin in it and I turned it 90 degrees, and since I did not say clockwise or counterclockwise, then I'm just doing counterclockwise. That's what you're always going to assume. Okay? Now, could I ask you a question? If I had said clockwise, if I had said turn this 270 degrees clockwise, or rotate 270 degrees clockwise, this is where I have to be visual. And then about the origin. Okay. Is this triangle rotated 270 degrees clockwise about the origin in the exact same place as the triangle that was rotated 90 degrees counterclockwise? So clockwise 90 degrees is going to be in this quadrant, 180 degrees will be in this quadrant, and 270 would be in that quadrant. Okay, it's just changing quadrants where they're going to be. Okay, so see that visual. If somebody says clockwise, well, I don't have a formula for clockwise. Figure out what it is counterclockwise. Does that make sense? Rotate 270, figure out which quadrant you're going to be. Oh, that would be just 90 degrees counterclockwise. Now, 180, it doesn't matter which direction we go, because 180 degrees clockwise lands in this quadrant, quadrant 3, or 180 degrees counterclockwise falls in this exact same quadrant. So 180 degrees, doesn't matter if I turn to the right or turn to the left, 180 degrees, I'm still facing the same way. Okay? So the 90 and 270 can just switch. All right. Should we do another one? Trying to keep these shorter. But I feel like I need to do one more, which I didn't do a graph page for. So I will. Because it's very, if you're doing transformations, you almost have to have graph paper. All right, let's see, what other type of shape do I want to do? Triangles are just nice and easy. But we could do a rectangle. That's just going to be way too easy, though. But it's okay. So W, X, Y, and Z. And if I said, I probably need to give it coordinates. 1, 1, 3, 1, 1, 2, 3, 5, and 1, 5. And if I ask you to rotate, rotate 270 degrees about the origin. Can you figure out which quadrant you will be in? They don't ask you any time in this book. You won't do any unless you are majoring in math and doing geometry specifically. You won't have to rotate anything other than 90 degrees. Okay, just know that. So 270 will go 90, 180, 270. So which one would be the equivalent? What if I said rotate 90 degrees clockwise about the origin? You'll be in the exact same place. So these two statements are the exact same. Okay? So here we go. Let's rotate. And I'm looking back at my transformation for 270 degrees. And that XY maps to Y negative X. So they're still switching places, but this time the X becomes negative. Sorry, technically the Y becomes negative. So here we go. We're erasing that little dot that's there. So the first point, I'm going with 1, 1 because it's beyond easy. So it becomes 1, negative 1. That would be W prime, which would be 1, negative 1. 3, 1 would become 1, negative 3. Okay, so that would be my X prime. Okay. Next, so this line right here is this same line that's rotating it about, and it still has to be perpendicular to it. Next, what about 3, 5 would become 5, negative 3. And that should be Y prime. 5, negative 3. So that's this line. They are perpendicular to each other. It makes sense. And then Z prime, I shouldn't have to count it. I should just know where the rest of that rectangle lies. But you can always say, oh yeah, it's 5, negative 1. And then there's my rectangle. Okay? It has rotated 270 degrees counterclockwise or 90 degrees clockwise about the origin. Okay? Because there's still this piece right here that we're rotating it about. Okay? Are you ready? Next, what happens if we don't rotate it about the origin? Okay? This one gets a little tricky and they only ask you like one question. So if we rotate something, rotation that is not about the origin. And there's a formula. And we don't use it too much. Okay, but you have to know it. I think there's one problem in the practice, and we'll do it. So if a point, and they only do 180 degrees, it's the only one they ask you, so they just kind of talk just about that one. If a point, x, y, is rotated 180 degrees about the point, AB. Okay, here's your formula. Okay, so it's rotated about some random point that's AB. Okay, your transformation of XY will map to be 2A minus X, comma 2B minus Y. Okay, so let's start with just a simple singular point. If we have, for example, let's take the point, what did we do earlier? 3, 2. Okay, that's my XY. And we want to rotate it, that point, about the point, I'm just going to do 1, negative 1. Okay, so this would be my A, B. You're plugging in a formula. That's all you're doing. You're taking a point. We're going to transform 3, 2 into, and we have to say 2 times A. What is my A? 1. Minus X. Back here is my X. Minus 3. I didn't mean to put a point. See, that's a comma. Okay? Comma, which will be your Y point, is 2 times B, which is negative 1, minus Y, which is 2. Okay? And you have to solve this piece. You have to solve, what's 2 times 1? Minus 3. So really, what is 2 minus 3? Negative 1. 2 times negative 1 is negative 2. What's negative 2 minus 2? It's negative 4. Okay? So this point that was 32 is going to map to be negative 1, negative 4. Okay? Let's look at a problem. All right, let's rotate. What do we want to rotate? I need a grid. Sorry. Should have done more. I don't know why I wasn't thinking. Here we go. Let's just do a triangle shape and let's see. Again, I'm going to change it. So this falls out here. Okay. So now we have A is 1, 2, 3, 4. 1, 7. B is 7, 1. And C up here is 2, 1, 2, 3, 4, 5, 6. Okay, and I want to rotate it 180 degrees, sorry. So we're going to rotate triangle ABC 180 degrees about, oh, I have to pick a point, don't I? We're going to pick a point that is negative 1, 2. Okay, so negative 1, 2 is right here. So that's some point P that we're going to rotate this shape around 180 degrees. Okay, so it might actually fall off of my graph. Hopefully it won't. So I'm using my formula. Okay, I'm transforming xy to go to 2 times a minus x, comma 2 times b minus y. Okay, and I personally am going to go do all of my figuring before I start graphing. Okay, if I'm translating, I might as well say this in. Here we go. Now I want to translate the point from A, 4, 1. I'm going to go to 2 times, well, what was my A again? That's right, this is my A and this is my B. Okay, 2 times A, which is negative 1, minus x, which was 4, right here. Comma, 2 times B, B is 2, minus y, which is 1. So my A will now transform to be, what is negative 2 minus 4? That becomes negative 6. And then 4 minus 1 becomes 3. So point A becomes negative 6, 3. So 3, 4, 5, 6. There's my A prime. Okay? Negative 6, 3. What about B? Can we transform B, which is 7, 1, to be 2 times A, which is negative 1, minus your x, which is the 7, not parentheses, comma, sorry, 2 times B, B was my 2 up there, minus y, which is 1. So negative 2 minus 7 is negative 9. 2 times 2 is 4 minus 1 is 3. So it's on the same line. Negative 6, that's 7, 8, 9. That is my B prime, which is negative 9, 3. Okay? And obviously I'm drawing through my letter, and that's okay. And last but not least, we're going to do letter C. We're going to transform letter C, which is 2, 6. We're going to transform it to be 2 times A, which was negative 1, minus y, minus x, comma, 2 times B, B was 2, minus y, which was 6. Okay? So, 2 times negative 1, negative 2, minus 2, I get negative 4. 2 times 2 is 4, minus 6 gives me negative 2. So I've got negative 4, negative 2, 4, negative 2. There is C prime, negative 4, negative 2. Sometimes I even like to cut out little triangles and put a pen right here and say, does that make sense? If I rotate this 180 degrees, 180 degrees, these shapes should not be perpendicular, they should be parallel. So really I look at my straight flat lines and say, is it parallel to this straight flat line? Yes, it is. If I take it and rotate it, does it make sense where it lies? Yes, it does. But I'm going to go over here and use this formula all day long. Just know that only works with 180 degree rotation about a point A, B. Okay? All right. Oh, they do an amusement park, and I know this comes into play, so let's look at it. Look at the Ferris wheel at the right. I'm on page 512. A little dyslexic there. Find the angle of rotation that transforms M to move to M prime. Okay? So they're wanting to know what angles between M and M prime. Okay? So they count the supporting arms or the spokes of the Ferris wheel. Okay? And they're going to take how many spokes there are and divide it by 360. Okay, the Ferris wheel. Okay, the Ferris wheel example, they're going to take 360 degrees divided by however many spokes, or how many it's divided into. How many angles? I'll just put the spokes. Okay, and they count 20 spokes. They really count the baskets that people are in. Okay, so they take 360 divided by 20, and there's 18 degrees between each of the spokes or each of the baskets. Okay, and then you count from M to M prime, and there are 7 baskets wide. So then 18 times 7 is 126 degrees. The Ferris wheel must rotate 126 degrees for seat positioned at M to move to M prime. Okay, so that's kind of an application of it. So in your practice, letter C is going to be kind of the same problem. Okay, how many, the rim of the car tire, okay, is divided into how many sections. Take 360 divided by that number, and then just multiply it times how far. They're going counterclockwise, so it's not the short distance, it's the longer distance from A all the way around to point B. Okay? All right, here's your homework. Lesson 78. We're going to do the practice. And we're going to do numbers 1, 3, and 6. And that's all. All right. Until we meet again, until you hear from me, and we'll see each other later. Bye.